what? I'm not driving with you anymore.
Sorry. It's not then.
I got a question.
Okay, question.
So the last one, you changed the 12, right?
He's a nice boy. Yes.
On the last problem, you changed the 12?
Yeah?
Oh, that's why
I guess. I don't remember. That was
Yeah.
erased and gone.
Yeah, I didn't catch it. That's why my answers were like.
Oh, yes, I did, because it wouldn't have worked out. All right, so that's what happens when I make up things on the fly. So let's talk about parallel circuits. Parallel circuits. Parallel circuits. All right. So we've already talked about Ohm's law, where E equals I times R, and nothing has changed. So done. Check. Got that out of the way. Then we have Kirchhoff. Kirchhoff. Kirchhoff's laws. For parallel circuits.
We did both.
What?
We did both.
I did both what?
He did both. Kirchhoff law.
Yeah. Okay. So, but they're different for parallel. So this time, E total is equal to E of 1, which is equal to E of 2, which is equal to E of 3, on and on and on. Because the parallel circuit, I should draw a parallel circuit, it looks like this. We talked about parallel means there's more than one path. So if I look at this simple parallel circuit, these two resistors are in parallel with my battery, which is to say that the amperage is going to come up, amperage the flow, and it's going to get to some point and go, well, the electron has a choice. It can go this way or it can go that way. So it's different. Two paths. So in Kirchhoff's law, E total is the same as E1, E2, E3. But I total is equal to I of 1 plus I of 2 plus I of 3, which is to say the sum of the amperage through each component is going to equal the total. So it's just backwards between parallel, right? So parallel, these two are kind of reversed. Now resistance, it's crazy. Resistance is written, it can be written, it's the inverse 1 over R1 plus 1 over R2 plus 1 over R3, and all of that 1 over. So it's the inverse, it's the sum of the inverses and the inverse of that. And another thing I will tell you is the total resistance is less than the smallest resistor. So if one of these is 1 ohm and this one is 2 ohms, guess what the resistance is going to be less than? Less than 1. Those are the rules. And why is that? Because it seems kind of crazy. You want me to wait? Okay. I won't shame you. You can stay here. Poor kid. Trying hard. All right. So kind of the best explanation I ever heard from this, which kind of made sense to me, is how many people go to the San Francisco? I said the San Francisco. San Francisco. Not very many people. When you go to San Francisco, or whatever, there's a big toll booth to go over any of the bridges. And so all the traffic kind of converges. Now, imagine if there's only one toll booth. And so all the cars have to go to one toll booth, and they all line up. And then there's another toll booth. And what that would look like, stop, go, stop, go. And that's kind of a series. But when you go to San Francisco, they got all these toll booths. And so if you have one, does provide resistance for the cars, right? Open up 2, is there more or less resistance for the cars?
Less.
So I add a resistor, but there's less resistance. So I add a third resistor, toll booth, I get even less resistance. So it works like that. It opens up a pathway for the electrons to flow, just like going over the Bay Bridge. And then they get over to San Francisco, and the electrons can poop on the sidewalk. That's what they do there. This only applies to parallel. But other than that, everything's the same. But let's talk about this resistance thing here and how does that work? So if I had, let's say, 3 resistors, I'll just say I have 3 ohms and 4 ohms and 5 ohms, 'cause I'm just making stuff up. Right now I can tell you our total is going to be what? Less than 3 is the correct answer. But how can I actually do this correctly? Well, I'm going to go to my calculator and clear this off. On this calculator, it is the x minus 1 right here. X minus 1, that is your friend. On Hannah's style, the one we were using, which I don't think anybody is, it's 1. It's actually literally says like 1 over x, right?
1 over x.
1 over x. I think it says 1 slash x, x or something like that. So same thing. So very different, but it's the same thing. So we're going to use the x minus 1, which is the same as 1 over x. So I had 3, 4, and 5 ohms, and I wanted to know what the total of that is. And so what I'm going to do is I'm going to do, oops, I want the pen. I'm going to do 3 x minus 1 plus 4 x minus 1 plus 5 x minus 1, and wait. So I'm going to catch up myself here. 3x minus 1 plus 4x minus 1 plus 5x minus 1 equals, okay, equals, now you're going to get an answer. Then I'm going to hit x minus 1. And it's going to say answer minus 1. I just hit equal. I'm going to hit equal. And the answer is 1.27. 1.27 ohms. Is 1.27 less than 3?
Yes.
So I probably did it right then.
Wait, I think I got mine wrong.
So I'm going to do a little bit slower this time. So 3x minus 1 plus 4x minus 1 plus 5x minus 1 equals. When I hit that equals right here, it's going to say 0.7833 repeating. Okay? But that's not the right answer. What I really want is 1 divided by 0.7833. That's really the answer, because if I go back here, it's resistor 1, x minus 1, 2, x minus 1, 3, x minus 1, and that equals some number, but we still have to divide that by 1. Yes. It still has to be divided by 1. So we come back to here, and so this number, but this is just plugged in my calculator right now, so I'm going to hit x minus 1, and then the display says answer minus 1. Then I'm going to hit equal, and that's 1.27. 1.27, right there. Yes? Everybody got that?
So, on the test tomorrow, most of our calculators have the cheat sheet thing.
Yeah?
Can we still use this for?
I don't think there's anything on there worth anything for you. I don't know. Telemetry, memory, probability, statistics, navigation, log answers, clearing and editing. I don't. What's on there that you want to use?
So,
I would say no. You do not want to be the person who's got a card out and you're kind of looking at a card. That does not look good. And if you're I think when you go to take tests, it's been a little while since taking them, but I think they take that kind of stuff away from you. They don't want to see that.
for
You
the
can use your calculator, but not the
voltage,
card.
this is just E plus E1, E2, E3.
Yeah. Okay. Let's do an actual problem then.
Okay.
So let's see. All right, so E, I, and R, E, I, and R, E, I, and R. We'll make this 6 ohms, and this can be 4 ohms, and this can be 12 volts. There you go. Get it?
No.
Wait. Oh, here's a little bit of grumbling. That's okay. So I'm just going to work this one. That's all right. In a parallel circuit, what can I solve for right off the bat? E, because 12 is the same all the way across. This is 12 volts, and this is 12 volts. Now, wait a minute. Why is that 12 volts? I mean, how come we don't have this voltage drop? Well, why don't you think about it? If I put a voltmeter right here, what's it going to read? If I put it right here, what's it going to read? Okay, same thing. If I put it right here, what's it going to read? It's the same thing, isn't it? Okay, and this wire is really an extension of that wire, so this is also 12 volts. So all that is 12 volts. So if that's all the same, I clean this up a little bit. If that's all the same, then that is all 12 volts. Now, did you solve for R?
Yeah.
Okay. Now you can do this one of two ways. So you can solve for R using the x minus 1 key, or I could solve for I. What is I? E, I, R. I went I, so it's E, 12 divided by 6. So 2 amps, and this is 3 amps. Therefore, the amperage here is now 5 amps, and R, which is 12 divided by 5, is 2.4? Okay, but I'm going to check that, 2.4 ohms. I'm not going to just trust this. So number one, rule number one, is 2.4 less than the smallest?
Yes.
Okay, looking pretty good. So 6x minus 1 plus 4x minus 1 equals 4.16. X minus 1 equals 2.4. Well, look at that.
So is it okay that I did the 6x1, 4x1 first and got the 2?
Absolutely. Yeah.
That's what I did too.
Yeah.
For this kind of problem, would they ever like?
Who's they?
I don't know.
Those crazy people.
Yeah. Would they ever like give us like 4.2 like the total R, and then like one of the R's, and tell us to figure out the other one?
Yes. There is an FAA question that does exactly that. And there is a formula that helps you work it backwards, except it's a little bit complicated, and I show you how to not do it. It's like one question, and I actually work through it, and I'm like, okay. But remember, it's always multiple choice. And so there is like an FAA test question that says something like, you have a parallel circuit with two resistors of 6 and 4 ohms, or no, with a total resistance of 2.4. One resistor is a 4. What is the other one? Is it A, 6, B, 10, or C, 12?
So you just put in every one and see which one.
Yes. It only takes you 3 tries. So it's this, that, nope. In fact, it's even easier than that because it's the other way around. They actually give you, it's not this, but they give you the 6, and then they say, is it 6, 10, or it's something, but I forget how it is, but all you have to do is remember it's smaller than the smallest resistor, and by default, you can just look at it and go, well, it can only be that one because of that rule. It's just that easy. So, yeah, I teach you all the little tricks like that. We work them together. All right. Let's see. Do I have anything else? Let's see. All right, you guys, that was too easy, so let's try another one. You guys are just too good.
I think I got it now.
All right. So. Three. Let's see. 12 volts. And 12 milliamps. 4 milliamps and 30 milliamps. Let's try that. And oops, I'm sorry. I shouldn't have given you those numbers. They're wrong. And you're not, I was trying to, I have certain things that are givens and certain that are not. So let's do this. Oops, even that's not right. 24. I got it here now. I'm with it. I'm on the program. 1K ohm, 3K ohm, and 400 ohms. There we go.
So what are those grounds?
These are grounds, which is the same thing as saying that it's all connected, because that's the way it would really look. I just saved a bunch of time. Now I'm going to SeaWorld.
I assume that's a new.
Yeah, I just did another one down here.
I'm not getting the right answer.
Yeah, this down here is a second one. So if you were really fast and you wanted to do this, you can work on this one down here below.
I'm like, this, we get dock points if we put like,
Ask it louder. Speak into the microphone.
if we were doing this kind of question
If you're doing this kind of question,
and we put like for the current we put like 0.0008 amps.
Yes.
We get docked off points because we didn't like just put 2 milliamps or something like
no, I do not dock points because it's right is right.
that. Okay.
So 0.008 is the same as 8 milliamps, as long as you put the amp. But if you put nothing, then you get it all wrong. So if it's 8 milliamps and you put 0.008, then I'll go, I don't know, is that 0.008 milliamps? And it's really, so you have to, as long as you put the suffix, you know, like I did right here.
What is that?
The last one is 3.6.
What? 3.6K. This is a whole nother problem down here. You guys are already working on the second problem? Who's ready to work the first? Who's not ready to work the first? 0010. What?
For milliamps, 100, or the, I got it.
Okay, let's work the top one.
Okay.
I shouldn't have put two on the board at once. I know, I see that. Top one, ready? Or are you guys just going to work the second one? Top one, what are you going to do first? This is a very, very easy one.
Get the resistance.
I'll do the resistance. Okay, what is my total resistance?
260.
1 second EE to third, 1 over X, plus 3 second EE third, 1 over X, plus 400, 1 over X equals, 1 over X equals 400. Is that what you guys got?
No.
No, I screwed something up. How about 260?
Yeah.
260.869, so that'd be 0.87 ohms.
But that's,
Somebody asked how many decimals out you wanted.
There we go.
so,
So yeah.
so if
What's
I-
that?
But if I rounded those up to 1,000, 3,000, and 400, that would still be. the-
These aren't rounded. They are 1,000.
Yeah, I'm just saying, if I did it that way, would you want it, well, actually, would you want it in kilo ohm, 1,000 ohms written that way, or you?
I do not demand it be a certain way.
Okay,
If it's kilo or milli, you can put what you want.
okay.
Okay, what's next here then?
Volts all the way. So you can, so hopefully,
Volts all the way. I like that. 24 volts. 24 volts. 24 volts. Now we can just solve for each one of these if we want. And we can solve for this. So that's just simple 24 divided by 260. 24 divided by 260.87 equals, what'd you guys get?
0.092 amps.
0.092. Then right over here we got 24 divided by 1,000.
0.024.
0.024. This one is
0.008.
0.008 and 0.06 amps. Okay, 0.06. No, double check. Clear. 0.06 plus 0.008 plus 0.024 equals 0.092. We are good.
Nice.
All right, you got this one?
Is that 306 over here on this?
3.6K.
3.6.
I'm gonna roll it up. How I can write it bigger?
Question for that?
Yes.
So like my E's and my I's are correct, but my R for the total is wrong. So what I hit is just like 1,000, and then the X1
Okay.
plus 3,000.
X1.
And then 400 X1.
X1 equals. Now hit the X1 key. Again. Now hit equals. There's your answer. Don't forget the last 1 over X.
Yeah. Alright.
I forgot how you said it.
So
Yeah.
it's
How would you do
the-
it on this one?
X divided by 1. 1 over X. 1 over X.
So I'm
Oh,
like,
the one over X button. next
Yes.
to I.
I'm lost myself.
Sorry.
What is 3.6?
Did you get lost on this one?
Yeah.
All right.
3.6K, is that 3,600?
3.6K.
Right.
Well, when in doubt, it's 3.6 3. The calculator knows. But yes, it's at, we're going to move it 3 places over. 1, 2, 3. So it's 3.6000. So it's 3.6, 1, 2, 3. So that is 3,600.
Okay.
All right, so where would I start here? Well, I would probably start right here with this E right here. So E, I times R. So this E right here is 360 times 100 milliamps. So I would do 360 times 100 EE second negative 3.
Second EE three,
Negative 3.
negative
It's got to be negative 3 because it's a milli,
36.
which is actually 0.1. So got 36?
Yeah.
36 volts. That means this is 36 volts. That means this is 36 volts. That means this is 36 volts. Now I can solve for I all the way down the board. Well, except for this one. So I could do I right here is E divided by R. So it's 36 divided by 3.6K. So 36 divided by 3.6 second EE to the third equals 0.01. I would do 36 divided by 900 equals 0.04. And so this must be what? Now the problem is I got right here, I got 0.04 amps, 0.01 amps, and over here I got 100 milliamps. So what is, I could convert one thing or the other. This is actually equals 0.1 amp. Or I could convert these. That's 10 milliamps, and this is 40 milliamps. But anyway, 0.1 minus 0.04 minus 0.01 equals 0.05. So this has got to be 0.05. So 0.05 plus 0.04 plus 0.01 equals 100 milliamps. Now I can solve for this. See, there's always a way. There is that formula where you can, how you can figure out how to find the missing resistor, but I found it this way. That's just even easier. R, so it's E, 36, divided by 0.05 equals, that's 720 ohms, 720 ohms. Now we can double check this and see if it worked out right. So I do 720, x minus 1, plus 900, x minus 1, plus 3.6 second EE the third x minus 1 equals x minus 1 equals 360. Boom! It's just so simple.
Wait, so
Why are you looking at me that way? Huh?
to get it,
I don't know how you did that.
How we did what? Got the 360?
I did all that, and I put it in my calculator, and I got some weird number.
Well, make sure you clear it. Let's do it over time. Oh, yours is a little bit different, but every time I say x minus 1, you just hit 1 over x.
Uh-huh.
Hang on. Yes.
So for the diagram we're gonna draw, we don't put P's on that?
Yeah, you do. I just haven't been doing the P because I'm trying to keep it simple and to succeed. Because we already did P. What is P? P is watts, and P is just I times E. So we
I'm just
can,
trying to see if you wanted it on there.
if I don't ask for it, don't worry about it. All right, but back to Hannah. We're going to double check our resistance. It's 720, 1 over x, plus 900, 1 over x, plus 3.6 second EE to the third, 1 over x. It's 3.6K.
So it'd be
Equals,
1,600.
oops, did I say negative? 1 over x equals, no, I did it right.
Oh,
Got it?
I hate this.
You just fat fingered it. Don't worry about it. Okay. Just to give you an idea. So Dean Webb talked yesterday about, hey, if your math skills are kind of low, consider if you don't go in the program, if you don't pass the class, to really take some math classes. And there are some great math classes, because I'm just going to show you real quick. I'm not even going to solve it, but this is something that you should be able to easily solve in in electricity class. So, oops, I can't even write it. But I just happen to have one in here that came from that class. So, if you have a parallel circuit with a motor that is 7/8 horsepower that happens to be 65% efficient, and Oops, we'll make that a light bulb. A 100 watt light bulb and a 2 ohm resistor. Solve for that. And it doesn't get it doesn't get much more complicated. This is pretty complicated for most people, but you can see that it's just a simple series parallel circuit because all circuits are parallel, really. You don't see much other than that unless you're inside of a specific component, but aircraft are all wired in parallel. So you just have to start worrying about, doing the math here on 75% efficient, 7 to 8 horsepower. But that's not even that hard because we know that a horsepower is 746 watts. So now we've converted that to watts, but we do 7/8 times that, and then divide by 65% because we have the efficiency, so it's going to go up. And see, just, it's just math problems. We just do a lot of this kind of stuff over and over, and that's the kind of stuff that's on the tests. Not tomorrow, don't worry about that. So, all right, I do have a little quiz for you. So you do the quiz, turn it in, and then we'll review a little bit.
Great.
Yes, it's graded. Told you yesterday it was going to be a quiz. This is simple.
Can I use my notes?
No. You can if you want a 0. You don't need your notes. It's just that easy.
Get a scratch paper out, right?
Scratch paper calculator.
A blank piece of scratch paper.
You can write on the quiz. In fact, I'd prefer it if you did. You start by putting your name on the top.